Hi learners, welcome to the today's topic. Our today's topic is classification and prediction, definition and terminology. So in the today's class, I'll discuss about what are the important terminologies are there and what are the definitions are there related to classification and prediction. Myself, Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So today I'll cover the classification and prediction with the definitions and terminology. What is classification and prediction? So there are basically two type of data analytics that can be used to extract models. Describing the important class, what are the important class levels are there, are predicting the future data analysis. So these are the two types of data analysis we can do. Now, so these are two forms are as follows. First will be the prediction, second will be the classification, right? So these are the two forms of the data analysis. So we use classification and prediction to extract a model representing the data classes. So we have already seen how we are going to classify the data on the basis of class labels, and although we are going to predict about the future data analysis, future data trends a pattern, right? So what is the exact definition of classification? So classification, basically it is going to predict the categorical levels of data with the prediction model. So basically that will work on the categorical type of class levels, class data levels, right? So this analysis is going to provide us with the best understanding of the data at the while we are having the large amount of data in the database. So the classification model, that is predicting the categorical class levels, right? On the other hand, the prediction, that is going to predict about the continuous valued functions. So this is the main difference between these. Why we are using the categorical data class levels, we have to use classification. If we are having the continuous value data, then we have to do the prediction. So that will that we have to do for the future data analysis. So we have to find about the what is the future trend on the basis of the past trend. For example, if we have to build a classification model, so we have to categorize a bank loan application. So suppose a bank employer is there, he have to do the bank loan he have to go through with the bank loan applications, he have to approve that. So either he have to classify it as a once if the user is risky, if the loan we have to give them, so that that will be risky for to us, other it will be safe for us. So on the basis of the CIBIL score of the particular customer or user. So on the for that we have to predict about, so the bank employer, so he if for him we have to do the future data analysis on the basis of the customers past data records which the bank having from their application, from which time he is using his the same bank account, what is the PAN credentials are there, what is the whole analysis is there on the PAN. So on the basis of that, the CIBIL score will be calculated and then the future data analysis will be done. So for the predicting the expenditure in dollar, so for the potential customers on the basis of computer equipment given on their income. So here on the basis of income and as well as with the occupation, what is the occupation of the that particular customer while he are going to apply for a bank loan application. So in this example, basically the bank employer who is going to give the loan to the customer, he will go through with the past data which is having the income and occupation of that particular customer. So on the basis of that, he have to check whether the customer is able to expend that amount of data which is calculated for the 1 month loan, for the how many years he have to take that loan. So on the basis of that, the two of the classification will carry out. First is safe, either the customer loan is the customer loan is applicable as a risky as well as the safe. So on the basis of these two classification of that particular model, we will able to the bank employer will be able to give the loan to the particular customer. So in the right hand side, we can see the classification and prediction process, how it will be gone. So in the classification, there will be have the training data. There will the data will be all the data will be that will be classified as a training data. On the basis of that, we will apply the classification algorithm, and then the classification rule will be carried out after that algorithm, and then that will be going to give the classification on that particular rules. On the other hand, the prediction will taken care of, that will have the test data. On the basis of that will be divided into the test data as well as the training data. So the both will be there for the prediction, and then that will be applied, the classification model will be applied, and then the classification will be carried out, and then new data will be carried out from that, and then the prediction result will be taken care for future analysis, future pattern analysis. So like this, the classification and prediction process will work on. Now, what is classification actually? So in the definition form, the classification is to identify the category, we can say class level of a new observation, right? So this is a particular definition of the classification. In that, first a set of data is used as a training data. Next, the set of input data and the corresponding outputs are given to the algorithm, as we have seen in the earlier figure. So after that, the training data set includes the input data as well as the associated class level. So these two will be associated automatically. Now, using the training data set, the algorithm is going to derive a model to the model, we can say the classifier. So on the basis of the training data set, the algorithm is going to give the classification. It is going to give a model. So now this derived model can be used as a to in the form of a structure, in the form of pictorial representation. It is going to seeing in the form of mathematical formula, some of the association rules, in the form of a decision tree, as well as in the form of neural networks. So this was the whole process, how the classification is going to work. Now, in the classification, when unlabeled data will be there, that is nothing but that is the training data. So, no, sorry. So, what is unlabeled data is that training data. So, in the classification, there will have the labeled data that will calculated as a training data. Now, when we are going to see the future trend of that data, future pattern of that data, that will be unlabeled, that we don't know in which class the same record will go for which of the same class. Then, so that if that we have to give for the model, that for the derived model, it should be found the class with the which it is going to belong, right? So that will be the process how it is going to classify. The new data will be provided to the model, and then that is going to give as a test data set. So that will be combined into the test data set. Then it will be applied for the classification. So that was the classification. Now prediction. What is prediction? So following are the example we will take on the basis of example, we will understand what is basically prediction is. So suppose a marketing manager is there, right? Suppose a marketing manager is there. He needs to predict about how much a given customer will spend during a sale. So if a particular sale week is there, holiday weeks are there for his company, so how much a particular customer is going to spend for that particular sale. Then in this example we are bothered to predict a numeric value. So here we have to spend what is money, so that will be in the form of numeric. So therefore the data analysis task is an example of numeric prediction. So prediction is all about that will have the all type of numerical data, right? So now in this case a model, we can say predictor, will be there, that will be constructed, and it is going to predict about the continuous value function, we can say ordered value, right? So although it is called as a prediction, the other name also can be there as a regression, that is growth. So growth regression in most of the cases is used for the prediction. So what will be there, because we have the business the business users, or we can say end users, he have to identify the future data pattern on the basis of the old data, historical data. So what he want to see, he want to compare the the marketing manager, he wants to check about the what is the sales money, what is the sales graph is there in comparison of the other of the company. So basically it will be the growth of the company, it will be the regression scale. So in most of the cases it will be used for the regression. So predicting the price of a house rely on the cases such as the number of apartment is there, what is the total region is there, what is the future trend will be there, how much cost will be there for that particular flat. So these are the some example is there that will be taken care for the, that will be take for the prediction. So these type of problems we will carry forward for the prediction of that particular future analysis. So an organization has the power to find out the amount of banknotes payout to the person, that is during a negotiation. So that will all have the regression of growth type prediction type of problems and solution. Now, what is the difference between classification as well as between prediction? So basically the classification is the method of recognizing to which group a new process belongs to. A background of a training data set will be there containing a new process of observing those particular training data set for whose group membership is familiar. On the other hand, the prediction is the method of recognizing the missing or not available data for a new process of observing. So that can also be followed if missing data is there. So we can predict, like we don't know about that unlabeled data, so we have to know about the particular class for that. Now the classifier is built to detect the explicit labels. On the other hand, the predictor will be built to predict about a current job, or we can say command value. So what is the current job, what is the future role can be there. So like this type of prediction, this type of assumptions, that will be taken care for the predictor. In classification, authenticity depends on the detecting the class level correctly. So what is the training data is there, how correct the training data we are having, what is the how valid the data is, how correct the data is, that is in the training set. So training data set, so that will all depend on that, and the authenticity will be carried forward for that particular data while we are detecting the correct class levels. But on the other hand, in prediction, the authenticity depends on how we are going to tell, how well a given predictor is going to guess about how it is going to predict about the unknown value, unlabeled data, of a on the basis of a predicted attribute that is already there for the new data set, for the new class level. Now, in prediction, the sample can be called as a classifier. On the other hand, in prediction, the sample can be called as a predictor. Again, in classification model, that can be represented in the various forms. So, the classification model we are using, right, for to predict about the for to understand what is the class of that particular data. So for classification model, we are having the some of the rules, some of the methods, so that will be carried forward. Here we have taken the example of if else rule will be there. There will be the new we can say neural network. There can be the decision tree. So any other form can be in the form of classification. So first rule is if then rules. So the rule based classifier we can also say to this. So rule based classifier make use of a set of if then rules. If then rules will be there. If and then. So if then rules will be there to after the giving all the values to the model. So the if else rule will be carried out there as a classification rules. So that rules we can express in the form of if will be there, then we have to write the condition, then and what is the conclusion of that particular condition. So let's consider example in that we are calling a rule as a R1. So R1 is equal to, it is having the student having the class undergraduate, and it is having the concentration in the brackets level comma high. That depends on the class A student, class undergraduate and concentrated level low. That depends on class B student, class postgraduate here, and that depends on class C. So this is the rule written here for the if then rules as example. So other form will be the decision tree. On the basis of that we can do classification. So that will be looks like a tree like structure. Here in the right hand side we can see. So in the what is decision tree actually? Decision tree is the most powerful and popular tool over there for classification as well as for prediction. So a decision tree, a flow chart like tree structure where each internal node, these are the internal nodes. So each internal nodes denotes a test on an attribute. So for this attribute that is having the test. On the other hand, each branch, this is the branch that is the outcome of an test. So after that, what we will found, that will be the outcome. And the each leaf node. So this is the leaf node, that is the lowest node. So each of the leaf node we can say as a terminal node that holds a class level. So on the basis of that those values, what is the class relevant class is there, class level is there for that. So this is nothing but that will be depicted in the form of decision tree. Neural network. So another form is neural network. So the main purpose is to use the neural network. We have to try to find out the relationship between the features in an data set. So what are the features are there in a particular data set and what is the relationship between them? And it is also consisting of a set of algorithm, and that is going to tell about the work of a human brain. So basically it works like a human brain. In that human brain, in the right hand side we can see in the human brain also the spikes will be there. There will be the neurons. There will be the sum of the, we can say, neurons related to the antibody. So a neuron in a neural network is a mathematical function actually, while we are using it in the form of classification. So that holds the mathematical function that is going to collect and calculate and classify the information according to the specific architecture. So in this right hand side example, that there is a neural network and that is having the sum of the neurons. These are the neurons, and that will have the these are nothing but that is having the network, that is shows as a network. This is the network. So that will that all looks like exactly as a human brain, and in that there also will be having the weights and biases to do the mathematical analysis. So there will be the function that is having the weight and bias. On the basis of that, each of the calculation will be carried out for the next stage. Like this, the all the working will carry forward. Now, how does classification works? So there are basically two stages of that classification system. So there are two types. On the first, that is classifier, or we can say model creation. So if suppose we have to create a model, so that is also going to tell about the class levels, right? Another is classification classifier, right? So we will go with the first, building the classifier a model. So this step in the learning stage, or we can say learning phase, that will be called as a learning of the phase, because that is where have to train the data set. So in this step, the classification algorithm that is going to build the particular classifier. First we have to give the model all the training data set. Then on the basis of that, the model is going to learn the what is there in that data set, and then the classifier will work for the new data set. So the classifier is built from the training set made up of database tuples as well as the associated class levels. So that in the right hand side we can see there will be the training data set like this. That is a, suppose one table is there that is having the class levels, name, age, income and roles decision. Then the classification algorithm is going to be applied on that. Then there on the basis of that, the classification rules will be taken care of. So now that these are the classification algorithm that will be going to give the classes for the classes labels. On the other hand, each of the tuple that constitutes the training set, it is going to referred as a category, a class. So that I have told in the last that will be categorized as a class level, a tuple. So these are the tuples can be referred as a sample object or data points. So what is we are having in the training data set, that we can also call as a sample object and data points. Other method was the using classifier for classification. So what is the why we are using the classifier for classification? In this step, the classifier is going to use. So we have built the classifier right in the earlier step. So here that classifier it is going to use as to predict about the test data. So test data is nothing, that is the unlabeled data. On the basis of that, the new data, if the new data will be given for which we don't know the level in which class it will go, for that it will be used. So using the classifier, the data will be used as test data, and that will be used to estimate the proper accuracy of classification rules. Also the classification rules that can also be applied to the new data tuple if the accuracy is considered acceptable. So like this the process will go on. In the right hand side we can see the using classifier for classification. In that the test data is there as same as earlier, and on that the classification rules has been applied, that is a basically classifier. On the basis of that, the test data will be given as unlabeled data. For that, the the model is going to tell about what is the class levels is there that we do the model don't know, right? So the classification and prediction having some issues there, while these are the two things, these are the two methods we are going to use for that prediction and classification of class level. So the major issue for preparing the data for classification and prediction can be preparing the data. We can have the some of the problems, some of the activities. So data cleaning first is coming as a data cleaning. So the data cleaning that is going to involve the removing the noise as well as the missing values. How we are going to give the remedy of that missing values, unknown value, wrong value, invalid value. So the noise will be removed by applying some of the smoothing techniques. Some of the methods are there. On the basis of that, we have to rectify the noise as well as the missing data. So on the basis of that, the problem of missing data will be solved by replacing a missing value with the most commonly occurring value for that attribute. So that can be one example, but many other methods are also there. On the basis of that, we have to do the data cleaning. Second is relevance analysis. In the relevance analysis, database may also have the irrelevant attribute. So that is not relevant. If we are using the sum of the data as a numeric, if in the other record that is used in the form of a string, so, for that we have to do the correlation analysis. It is used to know about whether any two attributes are related or not. If it's not related, that it will be discarded. So the relevance analysis will be the second issue for the preparing the data. Now the third will be the data transformation. While the data we can say data transformation and reduction we are using. If we are to we have to remove that data, we have to know about data, we have to change that data, if we have to replace the missing data, so that process will be carried out. So the data can be transformed by any of the following methods. So two of the methods are there to do that. First is normalization and second is generalization. So now the data is transformed using the normalization. Normalization involves the scaling all values for the given attribute in order to make them as a one specified range. There will be having the small specified range at a one scale. All the data will be changed as a normalized data. Now the normalize is used when in the learning step, the neural network or methods involving the measurement are used. The generalization, the data can also be transformed by generalization. So that is the second step. But on the higher concept, we have to do the generalization. For that, we can use the concept hierarchy. So as we have seen in the earlier lectures, how we are going to do the concept hierarchy. So that will be actually logical depiction of that particular data set. So in that we can do the normalization, in that we can transform the data. Now comparison of classification and prediction methods. So we have to compare we have to compare these are the two methods. Here is the criteria for comparing the methods. First can be on the basis of accuracy. So on the basis of accuracy of classifier, that is going to tell about what is the ability of classifier, how well the classifier is classifying the things, how well the classifier is predicting the things, predicting the class levels. So it predicting the class levels correctly, and the accuracy of the predictor refers to the how well a given predictor can guess the given value for the predicted attribute of a new data level. Second can be the speed. On the basis of speed, the computational cost will be calculated. So that is going to refer as a computational cost in generating and using the classifier as well as the predictor. So the accuracy and speed. Third is robustness. It refers to the ability of classifier and predictor to make correct predictions. So how correctly it is going to predict from any given data set, for any noisy data set, for any missing data set. So that will call as a robustness of data. In that the data will be very specific, that will be valid data. Scalability. Scalability is going to refer to the ability to construct a classifier, a predictor efficiently given large amount of data. So if large amount of data, scalability will be carried out. Interpretability. It refers to the what extent the classifier and predictor going to understand. So these are the things on the basis of these these are the five functions we are going to classify. We are going to tell about if classifier is good, if predictor is good. Next is what is data classification life cycle. So the data classification life cycle, it is going to produce an excellent structure. So for that, that is having the controlling the flow of data for any enterprise. So for any data warehouse business model, how the data classification life cycle will go on. So businesses need to account for the data security, as well as they have to compliance on each level. So for that, with the help of data classification, we can perform it as a every stage from origin to deletion. So in the right hand side figure, we can see this is the data classification life cycle. In that, uh, the origin will be there, then role based practice will be there, then storage of data will be there, the sharing of data will be there, archive storage of data will be there, and publication of data. So these are the few steps. On the basis of that, the uh, data classification life cycle will go on. So with the help of data classification, we can perform at every stage from origin to the how we are going to delete that data, how we are going to publish that data. So that data life cycle, that is having the following structure, that is having the following points. So origin, it is producing the sensitive data in the various formats, with the emails, with the Excel sheet, with the Word file, with the Google documentation, social media data, website data. So that will be the origin. So any type of data that can be there at the origin point. Role-based practice. Role-based practice restricts apply to delegate each data in the domain, in the form of domain, by tagging based on the in-house protection policies. What is the agreement policy? So all type of data will be protect from that with the help of policies. What is the agreement rules are there? Third, storage. So here we have the obtained data. What is actual data is there, including access, the control, and we have to apply the inscription of that. Sharing. So data will be continually distributed among the agent, consumers, co-workers from various devices and platforms. So that will be come in the sharing part. Archive. So the data will be eventually archived. So data will be eventually archived within a industry's storage system. So if that particular data is not dated, that will be archived as a eventually, for that point of time, that will be archived. Next is publication. So through the publication of data, it can be reached to the customers. How what is the reach of the that particular data to the relevant customer? So that will come under this. They can have the view, they can have the download, they can download these all from the dashboard in the form of dashboard. So that will all have the visualization and that we can say graphical representation of data in this phase for the end users. So that was all about the classification and prediction, definition, and terminology. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.